Hello dear students, welcome back. So this is your lecture number 3 of the chapter motion. Okay guys, so our first question is, during an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 to the power 8 meter per second. Okay, so now write what are the given values. The time is given and the speed is given. So the time is in 5 minutes, so we will convert it into second. So it is 300 seconds. And the speed of the signal is 3 into 10 to the power 8 meter per second. Now we have to find out the distance. So the formula here we will be using, we know that speed equal to distance traveled by time taken. Now solve it. This is a formula based question, you can solve it by yourself also. Well, I'm helping you out. Okay, now rearrange the formula. Distance traveled equal to speed into time taken. So now put the values. 3 into 10 to the power 8 into 300 equal to 3 into 10 to the power 8 into 3 into 10 to the power 2. So distance traveled equal to 9 into 10 to the power 10 meter. The answer is, the distance of the spaceship from the ground station is 9 into 10 to the power 10 meter. Clear everyone? Now move to question number 2. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So here this car is moving from point A to B and the distance is 16 meter in time 4 seconds. Again it moves from point B to C in time 2, but here the distance is same, that is 16 meter. Now write the given values. So the total distance travel is 16 plus 16 equal to 32 meter and the total time 4 plus 2 equal to 6 seconds. Now we have to find out the average speed of the object. So the formula here we will use average speed equal to, we know that total distance traveled by total time taken. Do it by yourself. Put the value for total distance traveled, that is 32 by total time taken 6. So we will get 5.33 meter per second. So the average speed of the object is 5.33 meter per second. Okay, now say question number 3. Usha swims in a 90 meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Usha. Okay, so see here, this is the length of the pool. From A to B it is 90 meter and Usha swims from A to B, that is 90 meter. Then again she swims back along the same straight path. Okay, so the total distance she covered as equal to 90 plus 90 equal to 180 meter. Okay, and the total time taken is 1 minute. So now total distance equal to 180 meter as Usha swims back to the same position. So the total displacement is 0 meter. Right? Now total time, it is in 1 minute. Now convert it into second, it is 60 seconds. So we have to find out the average speed and average velocity. So for finding out average speed, the formula is average speed is total distance covered by total time taken and average velocity is total displacement by total time taken. So note it down, these two formulas, they are very important. You can solve this sum by yourself because this is also formula based question only. So find out the average speed first. Now put the value for total distance covered 180 and our total time taken is 60. So we will get average speed equal to 3 meter per second. Now as displacement is 0, so average velocity equal to 0 meter per second. So the answer is, the average speed of Usha is 3 meter per second and her average velocity is 0 meter per second. So students, our next topic is acceleration and types of acceleration. Now see, you can see that the accelerator is present normally in your vehicle on your rightmost floor pedal. This is the accelerator. Now see the definition of acceleration. The rate of change of velocity is called acceleration. Here the velocity changes with time. Also you can see that on a busy road, the velocity of the vehicles changes with time. So acceleration equal to change in velocity by time. Here change means difference in velocity. So acceleration equal to final velocity minus initial velocity by time. Here the final velocity means the velocity after some time and the initial velocity means velocity in the beginning. Now acceleration, it is denoted by small letter a, initial velocity small letter u, final velocity small letter v, and time t. So acceleration a equal to v minus u by t. So this is an important formula for finding out acceleration. You can note it down. Now see the unit. So in MKS system, the acceleration is meter per second square, and in CGS the unit for acceleration is centimeter per second square. Clear everyone? Okay, now see, there are three types of acceleration. So it can be either positive, negative, or zero. Now see, when the acceleration is positive, so when the plane is taking off, the acceleration is positive because here the velocity increases. Okay, now see, when the acceleration is negative, at the time of a plane landing, the acceleration is negative because here the velocity decreases, or you can say there is retardation or deceleration. Now see, when the acceleration is zero, at the time when a plane is moving with constant speed, the acceleration is zero. Here the velocity is equal to constant. Alright students, now see question number 1. Earth rotating on its axis is an example of, so 4 options are given. So can you tell me the correct option? Yes, it is an example of zero acceleration. Now see question number 2. A car starting from rest and moving is an example of, so when a car is starting from rest and then it is moving, it is an example of, this is a very simple answer, so it is your positive acceleration. Okay, now see question number 3. The distance traveled by a body in a given direction in unit time is called, so when a body is traveled in a given direction in unit time, and it is called velocity, right? So see question number 4. Which of the following statements is correct? So 4 options are given. Now see option A. Units of speed and velocity are different. We know that units of speed is meter per second and velocity is also meter per second. So option A is incorrect. Now see option B. Units of velocity and acceleration are same. Definitely not, because we know that units of velocity is meter per second, but unit of acceleration is meter per second square. So they are not same. So option B is also incorrect. Option C. Units of speed and velocity are same. Yes, because we know that unit of speed is meter per second and the velocity is also meter per second. So option C is the correct statement. And option D, units of speed and velocity are same only in MKS system. Definitely not. So C is the correct statement. Okay, see another question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Here the initial speed is given 80 km per hour, so convert it into meter per second. So 80 into 5 by 18 meter per second. So after calculating, we will get 22.22 meter per second. And the final speed is 60 km per hour, so again convert it into meter per second. So after calculation, we will get 16.66 meter per second. So time t equal to 5 seconds. We have to find out the acceleration of the bus. So for finding out acceleration, we know that the formula is a equal to v minus u by t, right? So this is another formula based question. You can solve it by yourself. Do the calculation. So a equal to v minus u by t. Now by putting the values, we will get the value for a equal to minus 1.112 meter per second square. Don't forget to write the unit, this meter per second square, okay? So see here, the answer is, the acceleration of the bus is minus 1.112 meter per second square. Here don't ignore the negative sign, because here the negative sign indicates that the velocity of the bus is decreasing. Everyone clear? Okay, now see question number 2. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. So here the train is starting from the rest. So here initial speed equal to 0 km per hour and the final speed equal to 40 km per hour. Now convert it into meter per second. So we will get the final speed v equal to 11.11 meter per second. Okay, here the time t equal to in 10 minutes. Convert it into seconds, so we will get 600 seconds. Here also we have to find out the acceleration. So acceleration formula is a equal to v minus u by t. Now pause the video for a minute and do the calculation by yourself. Okay, see, I am also helping you out. By putting the values, we will get the value for a equal to 0.0185 meter per second square. Here also don't forget to write the unit. Okay guys, so the answer is the acceleration of the train is 0.0185 meter per second square. Alright, this is our last topic for today's lecture, uniform and non-uniform acceleration. Now see the definition of uniform acceleration. If there are equal changes in velocity of body in equal intervals of time, then it possesses uniform acceleration. So to possess uniform acceleration, there should be equal changes in velocity in equal intervals of time. So see here, I will give an example so that you will understand more clearly. To start with, the van is at rest. So at 0 time, velocity is 0. Okay, here the time is 0, so the velocity is 0. So after 5 seconds, the velocity is 8 meter per second. Likewise, we will see the time up to 35 seconds. So after 35 seconds, the velocity is 56 meter per second. Okay, now see here, as you can see that the difference between two instants of time is 5 seconds, right? Can you see it? So we can say that there is equal intervals of time. Okay, now see here, the change in velocity in the time interval is constant. Here it is constant, so equal changes in velocity, that is 8 meter per second. So we can say that the van is moving with uniform acceleration. Is that clear? Alright, now see for non-uniform acceleration. If there are unequal changes in velocity of body in equal intervals of time, then it possesses non-uniform acceleration. So to possess non-uniform acceleration, there should be unequal changes in velocity of body in equal intervals of time. Clear? Okay, here also I will give an example. See here, to start with, the van is at rest. So at 0 second, velocity is 0. Here, after 5 seconds, the velocity will be your 7 meter per second. So the velocity changes with time. Okay, so here also we will see the time up to 35 seconds. And in 35 seconds, the velocity is 52 meter per second. Clear? So see here, the difference between two instants of time is 5 seconds. Can you see it? So there is equal intervals of time. But in case of velocity, we can see that the change in velocity in time interval varies. It is not constant. So unequal changes in velocity. So we can conclude that the van is moving with non-uniform acceleration. Well students, this is our last question. When will you say a body is in uniform acceleration and non-uniform acceleration? Now first see for uniform acceleration. So if an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the body is said to be in uniform acceleration. So when an object travels in a straight line and if its velocity increases or decreases by equal amounts in equal intervals of time, so that body is said to be in uniform acceleration. So here one example is given, the motion of a freely falling body. It is an example of non-uniform acceleration. Now see when it is in non-uniform acceleration, if an object travels in a straight line and its velocity changes by unequal amounts in equal intervals of time, then the body is said to be in non-uniform acceleration. See when the object travels in a straight line and the velocity changes by unequal amounts in equal intervals of time. So that body is said to be in non-uniform acceleration. Okay, so here also one example is given. If a car is traveling along a straight road and passes through a crowd, so it suffers unequal change in velocity in equal intervals of time. So the car is moving with non-uniform acceleration. So is that clear everyone? Okay, so this is all about lesson number 8. So guys, if you want to do our live classes, then you can download our app Nakhyatra from the link given in the description box. There not only you can do the live classes, but also you can watch the recorded classes, and even online tests are also available. Moreover, to clear all your doubts, you can also interact with me directly. Thank you.